Okay. Hello everyone. Today I'm going to talk about how to train a drug-target interaction model from scratch using DeepPurpose. So in this tutorial, we'll talk about first about overview of DeepPurpose, and then talk about what the data input look like for DeepPurpose. And then in part 2, I will go through the DeepPurpose framework, which basically is using around 10 lines of code to do lots of drug-target interaction prediction using deep learning. So first, we load the DeepPurpose package, and then I'll talk about how to load the data. So we have two ways to load data. The first one is to using this read function that read from the local files. So for example, here I put a toy data set, and you can just call dataset.read file training dataset drug target pairs, and then it will automatically generate the data format that we want. So here we have X drugs, which is an array of drug smiley strings. X targets, which is an array of amino acid sequence. Y is an array of the affinity score, and the Y could also be like a binary score. The DeepPurpose framework would automatically detect that, and then transform these kind of loss function and etc. So here we visualize the first position of each of the array. Is that this drug 1 is this amino smiley string, and this target 1 is this amino acid sequence, and we see that it has this 7.365 affinity score, which is after the log transformation. And then that's one way to load the dataset. But during method development, we also have some like benchmark data loader. So for example, Kiba, Davis, and BindingDB. So to use, for example, to use the Davis, we can just call dataset.load process Davis, which would automatically transform the data, that download data, and then transform the in the designated format. So here's an example. So that's for the dataset, and now I talk about how do we use the framework. So the framework basically divides into these kind of steps. We have like first need to specify the encoders, because DeepPurpose provide like lots of encoders for drug and proteins. You need to specify the correct encoders in order for it to work. And the second is you need to encode the data in the encoder ready format, and also split the dataset into training, validation, and testing. And then you need to generate the model configuration and then initialize the model, or you can just load a pre-trained model and then just click model.train and then just training. And then we also show how to do model prediction, specifically repurposing and screening. And then there's also model saving and loading, which is also consists of one line of code. Cool. So first I'll talk about encoder specification. So DeepPurpose provides 8 encoders for drug, 7 encoders for target currently, and we're expanding more models. So here I use drug for using MPN, message passing neural network, and target encoding I use convolutional neural network. And this we designed this framework to be really easy to switch the encoders. So you can simply switch the name, for example, drug encoding equal to Morgan, which uses a deep neural network on Morgan fingerprint, and similarly for the target. So you can simply switch the name of the encoder, and then all the other things keep the same. So that's like we want to make it like a scikit-learn style training. Now we specify the encoder. We can encode the data into the encoder format, and also do the data split. So these two steps are wrapped into this function called utils.data process. So it will take in X drugs, like target and Y, which is the data, and then to specify the encoders, and then different split method. You can split it by random, code drug, code target, and also we recently provide a function called scaffold split for drugs, and you can also specify the train test validation fractions and the random seed numbers. So this will generate the data encoding that we want. So here, since we put MPN, it will generate this kind of tensor, and then since we put CNN for target, it will generate this kind of characters of the amino acid sequence. Then we can initialize the model with some configuration. In the configuration function, you can specify the models like kind of like different hidden size, hidden dimension size, depth size for CNN, like filters, kernels, like numbers filters, which is just the length of this list, and all various kind of stuff. You can also specify the optimization parameters like epoch size, learning rate, batch size, and etc. So here we generate a config file, and then we can initialize the model using models.model_initialize config. Now this is a model class that is able to do lots of stuff for training, validation, training, prediction, and etc. Okay, so now we can move on to training. We can just simply call model.train and then the file that is outputted from the data process function. Now we see that it will automatically detect the instance, and then it will also give some alert like it's done with data preparation, and go for training, and we can bring out these kind of different laws, and in each validation it brings out the MSE, Pearson correlation, and concordance index, which is for the affinity prediction task. And if you are doing like binary classification, it would automatically shift to AURC, AUPRC, and etc. And then in the end of the training, it will also plot this kind of loss values. Now we see that after training, it's like we can do like lots of predictions. So for example, we want to predict on this drug and this target's affinities. So we have this Y, and we can just do the same data process again, but in this time we do no split, and then it will automatically print the predicted score, which is here. And then we can also we also created some wrappers to do repurposing and virtual screening. So first we load this data set, which is if for example want to repurpose for this protein SARS-CoV-2 protease 3CL, we can just call dataset.load this protein, and then it will get the target name and the amino acid sequence. And then we also want to specify a library of the repurposing drugs. So here we use an antiviral drugs library, which is you can also specify dataset.load antiviral drugs. And then we can just simply call models.repurpose x repurpose, which is the library here, the antiviral drug library. The target is the target here, which is the SARS-CoV-2, and they'll specify the model and drug names, target names, and the result folder, and etc. And then it will make the predictions, and then print out these tables that is ranked based on the binding score. So we have this drug name and target name that they have this binding score, which is really high. And now we showcase how to do a virtual screening, which is quite similar. We load this sample from another data set that consists of drug target pairs. So this T is a sequence of amino acid sequence. D is a sequence of drugs. And then we can call models.virtual screening, DT, and model. It will also automatically generate a table along with the binding score. And then we can also do the save and load pretty easily. You can specify model.save models, and you can also easily load a pre-trained model from the local directory or from existing pre-trained files that we pre-trained for you. You can specify the pre-trained drug encoder, target encoder, and the dataset that is pre-trained on. And that's it. So that's the basic framework for drug target interaction prediction. And we also put more tutorials about drug property prediction using DeepPurpose, and also like using one line of code to do repurposing and the virtual screening. You can check out the Git repository here, or you can send me an email for more questions. Thanks.